Today's lesson is understanding and graphing inequalities. Let's look at your student objectives. Today you're going to learn three different things. You're going to learn what an inequality is, what an inequality represents or means, how to model an inequality using a graph. All right, let's start reviewing what we have been focused on in equations. An equation is when we have a system that is perfectly balanced. Okay, so for example, let's say I had an unknown plus a 7 is equal to a 10. That would mean I have a situation like this picture where I know this side perfectly balances with the 10. In other words, the scale would be completely level. So now to find this unknown, I've got to think what number added to 7 is 10. And we can see right here what number added to 7 is 10. That would be a 3. So since both sides have 10, that is why it is a balanced system, balanced situation. An inequality is different. In an inequality, now we have an unbalanced system. So for example, now let's say x is greater than 10. So now, because x, our unknown, is a weight that is larger than 10, it would cause this side to drop down because it's heavier, and the side with the 10 would suspend in the air. So now we're working with situations where we have something that is perfectly unbalanced, and we need to make sure that we don't do anything that is going to disrupt the scale. In other words, we don't want to make the scale tip to where it's unbalanced in a different way. All right, we have four different types of inequality. The first one we're going to look at is greater than. The symbol looks like this, so let's talk about what it looks like. We call this the open end, points to my left. The closed end, or sometimes you'll hear me call it the point, points to my right. When it looks like that, that's called the greater than symbol. Some kids get confused on these and they need a way to remember it. So this is what I typically say for those kiddos. When it points to the right, R for right, the word greater than has the R in it. So you're looking at the greater than symbol. So let's look at this inequality. We know the unknown is something greater than 3. So we know right here represents our unknown side. And this is our 3. The reason I know that is because the unknown is greater than. That's going to cause my scale to drop down. So now let's think about values that would cause this to be true. What are some possibilities of numbers, weights, that would cause that scale to drop down? Most kids automatically go to 4. They might even say, I'm going to go to this side over here. 5, 6, 7, you get the point. But don't forget, decimals and fractions also work. In fact, any number, even just slightly greater than 3, the tiniest little bit more pounds would cause this side to drop down and be heavier. Okay, so that's what an inequality is looking at. So we could also be looking at decimals, all sorts of fractions that do have the number 3 in them, but when we have this that we call a little bit more, that causes it to drop down, which causes the inequality to be true. So any value, whether it's a whole number, decimal, or fraction, that is larger than 3 causes this to be true. Now let's look at this symbol. Let's first talk about what it looks like. Less than. Now my point is to the left. L for less than. When the symbol looks like that, that is the less than symbol. So in this inequality, now my variable, my unknown, is less than 3. So now I still know this is my variable side because the part that's less than would now be suspended in the air. This side has a 3. So let's talk about numbers that would make this statement true. So it's any number less than 3. The whole numbers are easy. 2 is less than 3, 1 is less than 3. Don't forget 0. Nothing's less than 3 for sure. Any negative value. However, just like before, we also got to think about our decimals and fractions. So any decimal that is less than 3, it could be the slightest bit less than 3. Something like that. That's a tiny bit less than 3, but it would still cause that side to suspend in the air. So then again, it could be a fraction that is a tiniest bit less than 3 would also make that true. So don't forget about your decimals and fractions that also make that value true. All right, this is the greater than or equal to symbol. We know it's greater than because the top part, my point, is pointed to the right. That's the greater than symbol. But there's something added to it. Actually, what it is part of an equal sign. What happens here is you have the equal sign and the greater than symbol combined. So what they're trying to get you to see is the meanings combined. We have two possibilities. It could be, like in this inequality, a value that's greater than 3, also a value that's equal to 3. Either one will work. So that is why we have to keep in mind we have both situations. We have where x could be on this side, and then 3 is here, and what could go into that pan? Well, any number greater than 3, we've talked about that, 3.00001, 3 1/4, 4, 5, 6, 7, 8. But then also, because of this symbol, we also know 3 could also go in that pan. In other words, it could also be equal to. And then finally, we have the less than or equal to symbol. Notice the point is to the left. Okay, so this inequality says x is less than or equal to 3. So of course, we again have two situations. It could be where it's suspended in the air. So our x is here, the one that's lighter, and 3 is heavier. So now we're thinking about numbers like 2.99999, 2 and 99 hundredths, 1, 0, anything lower. But then we got to remember, because of the line on bottom, 3 will also work because this is something that can be suspended or equal. Both situations all at once. All right, so now let's look at how we model these, because there's so many numbers that can make these true. In each one that I talked about, I showed you multiple numbers. That's why what we end up having to do is use a graph to show them. Okay, so the graph, I want you to notice, has two parts. There's a circle. Now on the top two, notice the circles are empty, open we call that. But on these bottom two, the circles are shaded in. We call that closed. So those have two different meanings. Then we have a line. The lines are drawn because of what I've been talking to you about. Whole numbers make these true, but then so do all of the decimal and fraction possibilities. So therefore, since we've got an infinite amount of numbers that will make these true, we draw that solid line showing the infinite amount of numbers. So let's go ahead and think about this. First of all, we're going to talk about each graph. The first one, the top one, that's representing this situation. So when it's open, we're looking at when we're only looking at a situation that is unbalanced only. So that's when we don't combine the equal sign. So let's think about what this graph is telling us. This means, because it's open, 1 is not included. So I know I'm looking at this picture. And these are numbers that are bigger than 1. So what we would say here, the variable, which I'm going to use k, are numbers that are greater than 1. This bottom one, well, it would look like this. Okay, so it's where we only have an unbalanced situation, Because this is open, it is not closed in. I know it cannot include 1. And then the line shows numbers that are less than 1. So this one is showing K is our numbers, all numbers less than 1. So your middle one here, or your third one, that represents both situations. The reason I know that is because this is shaded in, so that's when we include the fact it could be balanced. So we've got the numbers here. Think those are numbers that are smaller than 1. So this is showing K is less than or equal to 1. And then finally our last one, we have both situations. The reason I know that is because this is shaded in. The line shows numbers that are bigger than 1. So that graph is showing me the number K that is greater than or equal to 1. So a summary that you need to think about. When do we leave the circle open on graphs? It's when we have either the less than or the greater than symbol. And the reason is the number will not make the statement true. Let's go back to the one we were just looking at. K is greater than 1. What we mean by the number will not make the statement true. If I try to say K is 1, look at what we get. If I substitute 1 for K, we get 1 is greater than 1. That is not a true statement. Okay? So in this situation, you leave the circles open. And I want to hide the fact that I underlined those because it almost made it look like the less than or equal to. Okay? So some kids are saying, let's talk about what the symbol looks like. When you don't have that line underneath it, the circle's open. And that's very true. Let's look at the second one. When is the circle closed? It's when we have the line underneath it, and it's because now those symbols mean less than or equal to, greater than or equal to, and in that situation, the number will make a true statement. For example, if it was K is greater than or equal to 1, if I plug in 1 to that, 1's not greater than 1, but right here we go or equal to. And yes, it satisfies that part. Yes, it is equal to. So that is a true statement. And so that's why in that situation we do close the 1, showing 1 will make the statement true. All right, let's go to that last slide that we were just looking at. If you saw this inequality, you would say, okay, I'm looking for numbers that are greater than 1. So the first question typically is, should we open or close the circle? Well, ask yourself, would the number make it true? Is 1 greater than 1? No, it's not. When it won't make it true, we have to go with that open circle. So therefore, I could immediately eliminate these bottom two are not a possibility. Now I would want to think about the graphs. This one is, the line is on 2, 3, 4, 5, 6, 7. I'm going to focus on the whole numbers. I'm going to say, are those numbers greater than 1? Yes, they are. So therefore, that is a correct graph for K is greater than 1. The second one would not be a correct graph because when I look at the line and what numbers it's on top of, those are all numbers that are less than 1. And this statement is saying they have to be greater than, so that is not true. So that is how you pick out a graph for an inequality. And then let me go ahead and just off to a side note, let's make one up real fast. I'm going to do it in green. What if we had K is less than or equal to, let's go with -1. How would I sketch that graph real quick? Well, I'd make a quick number line. We typically tell kids, put your 0 on there. Look at your number, place it on the correct side of 0. Now, even it out, balance it out, put something on the other side. Okay, so usually we just use the opposite, so +1. Then you look at your symbol. Do you have the equal sign added? Yes, you do. So now when you graph it, put your circle and show that you're going to shade it in. Then we would think, okay, what side satisfies the statement? We want something less than 1. So which side has numbers less than 1. Well, right here is -2. Over here is +2. Which ones are less than 1? Well, it's the -2, isn't it? So now you draw a line going that way, and you put a line or an arrow on it showing the line would go infinitely that direction, because all of those numbers would make that statement true.